So welcome to this third part of the video of GATE 2020 Organic Chemistry 1 Marks question solution. First question, a nitromethane group has been reacted with a base with a diester compound and then zinc acetic acid provided. We have to find out P and Q. Now this methane group in the nitromethane is actually acidic. It has got an acidic H because the H actually participates extensively in conjugation, as you can see by the arrow pushing mechanism. It participates in conjugation with the phenyl ring as well as the nitro group. So now the base actually ETO minus abstracts that acidic H of the methyl, and then negative charge develops, which then attacks to the ester group, and we actually get a compound after OAT leaves. Now this dicarbonyl compound that we have found reacts with zinc acetic acid. Zinc acetic acid is a reducing agent which basically reduces the NO2 group, that is the nitro to the amino group, NO2 to NH2. Then the NH2 attacks one of the carbonyl centers, but the OAT containing carbonyl center is less reactive because OAT replenishes a little bit of electrons. It is an electron donating group. So what happens is NH2 actually attacks the other carbonyl which does not have the OAT, and then a 5-membered ring actually ensues via proton exchange also happens. And after that what happens is that the two H's that are present, and also acetic acid is present in the media, so aromatization occurs. One H actually eliminates, and H2O water is also eliminated, and we also get the aromatic product that we have as the answer. So this is basically a substituted indole product that forms after the overall reaction. So yeah, thank you. And in the next question, so I have already solved this question. So this is actually the 4A and 8A centers. RS configuration we have to say. So as you can see that 8A is R and 4A is S. So let us get into the detailed mechanism, the detailed procedure, how to find out this R and S configuration of this compound. So as we can see, for 4A center, the OH hydroxyl is basically the first priority group, as O is obviously first priority. Then we can see the second priority is with the C and O, and the third and fourth priority, as we can see, because in the third there is a C double bond C which counts for 2 carbons, whereas in fourth there is 1 carbon and 2 protons, 2 H's. So okay, now we have the priorities sorted out, 1, 2, 3 and 4. Now we will perform exchange twice, that is an even number of times, to keep the overall configuration unchanged. And now what this does is it brings the fourth group, that is the least priority group, to the back position, and after that we find out that the 1, 2 and 3 group, the priority groups, actually rotate in the anti-clockwise direction. Hence this provides us to the S configuration. So 4A has got S configuration. Let us see the priority in the 8A. So as we can see that the CHO group is actually second in priority than the C double bond O group, because the C double bond O group also has a carbon in the next after the carbonyl compound, whereas in the CHO there is a H after the carbonyl part, and the OH containing part has got 1 carbon and 1 oxygen, whereas C double bond has 2 oxygens, so that is third, and the least priority is the 2 carbons and 1 H. Yeah, so now we can see the priorities are sorted out. So again we perform exchange twice, and after that we again get the fourth in the least position, and hence we find out that it is R. So please check it out. I had actually solved this earlier.